To solve question number 2, 100 ml or 0.1 mole per dm³ ethanoic acid or acetic acid is mixed with 50 ml of 0.1 mole per dm³ sodium hydroxide solution, and the pH of this resulting solution is 5.0. What is the change in pH if 100 ml of 0.05 molar sodium hydroxide is added to the solution? Please, it's important for you to know that molar means mole per dm³. Yes. Now, I want to know whether this is acidic or basic buffer. So we have to represent what we are seeing with what? Equation. We have acetic acid plus what? Sodium hydroxide to give you what? Sodium ethanoate plus what? Water. The equation is balanced, right? Now we need to know the amount of this that reacted. The amount, they go by 1:1:1:1, right? Now we say number of mole of what? Acetic acid reacted. Number of this reacted equals to, you say 100 times 0.1 all over 1000. That will tell you how many moles of it reacted. You now say 100 times 0.1 divided by 1000. That will be giving us 0.01 moles. That means it's only these moles of what? Acetic acid that reacted. You do for sodium hydroxide, number of moles of what? Sodium hydroxide reacted will be equals to, this is 50 times 0.1 all over 1000. You now say 50 times 0.1 divided by 1000. That means we'll be having 0.005 moles. Mole. They are not more than 1 mole. Now, you notice that this quantity of sodium hydroxide and acetic acid, this one is higher than this, and they go by 1:1. That means that this is the acidic buffer because it has what? This and what? Is conjugate base. And we say that acidic buffer has an acid with its conjugate what? Base. If we say it is what? Sodium hydroxide, it doesn't have conjugate acid here for it that we will use. Now we say this and this, so acidic buffer. Now if here is 0.05, 0.005, because it's go by 1:1, this one is smaller than this. It means that here will be 0.005 because 1:1, 1:1 mole. So that means 0.005 for sodium hydroxide will react to 0.005 for ethanoic acid. Now once it reacts, how many of ethanoic acid will remain? The one that will remain is 0.01 minus what? 0.005. That will be giving you this remaining. So this will be what? Remaining. Yes. So they gave you the pH when we have this. You said that your pH is equals to 5 and is equals to pKa plus log what? Salt over acid. Concentration of salt over acid. Now this is 5. That means we are looking for what? pKa. That is what it means. Because we have gotten what? This react with this. This will now remain and it will produce what? 0.005, and it will also produce 0.005 more of water. So this reacting with this will be producing this in terms of 1:1:1. So once this neutralize with this, it will be remaining this of acid remaining. You note that the acid remaining is what? Acid remaining in that solution, first solution, is 0.005 mole. Then the salt form will be equal to 0.005 what? Mole also. So we are looking for pKa. We will be saying 5 equals to pKa plus log what? Salt is 0.005 all over what? Acid is 0.005. Now we say this over this is 1. Log of 1 is said to be 0. Therefore, pKa automatically will become 5. We have gotten our pKa. Now, in this same solution that is having what? 0.005 of ethanoic acid remaining, the base already have been neutralized. They said, what is the change in pH if 100 ml of 0.05 mole of what this is added to the solution? Wow. He said number of what? Number of what? Sodium hydroxide that will be reacting equals to 100 times 0.05 all over 1000. That will be giving you 0.005 mole. That is number of sodium hydroxide of this that will be reacting when you put it what? When you carry 100 ml of this and put inside the same solution. That means this is another sodium hydroxide you are adding. And already we have 0.005 of ethanoic acid remaining in this first one when you added this. This will now be remaining. So this will go to neutralize it again. And once you neutralize it now, it will also go and form another what? 0.005 of sodium ethanoate. That means 2 sodium ethanol will be having. This plus this will be giving 0.0. We now say 0.005 times 2. That will be giving us 0.01. Therefore, what you'll be seeing here now, there will be no acid remaining here because the second sodium hydroxide have neutralized the remaining acid. No base remaining, no acid remaining. Only salt and water is what we'll be getting. You will be having 0.005 plus 0.005. That will be giving you 0.01 what? Mole of what? The salt remaining. We call this what? What type of? This is a salt. And because this is a salt now, salt and water, that means that is what we'll be having. This is no longer, the result of this will no longer be a what? Buffer. It will no longer be a buffer. It will be salt and water. Are you getting it? So, as it is like this now, what you now do is, you now say, to get the pH of this, what is, we call this, is it acidic salt or basic salt? Is it acidic salt or basic salt? That is the question now. How we know whether it is acidic salt or basic salt is, we say this is sodium and this is gotten from sodium hydroxide plus what? A weak acid. This is a strong base and this is a weak acid. So this will be a basic salt. This automatically will be a basic salt. So basic salt. Because strong base will overshadow the weak acid, so it will give you a basic salt. So the resultant of what we'll be having is a basic salt. So we have this form and the another 0.005 of water form. So water is 0.001 total. The basic salt is also 0.001 because when you add this and this, it will give you what we have here. That means we will be going for now pH of a what? a basic salt. So since we have gotten the final thing to be a basic salt, we say pH of a basic salt is equals to half pKw plus what? Half pKa plus half log C. There is need for you to check our class on ionic and chemical equilibrium still on Chidons Daniel YouTube channel, so that you will see how we derive this formula, so to speak. Yes, because we had two formula there where we said pKw minus half pKb plus half log C. This is with respect to when pKa is given, and this is with respect to when pKb is given. Now, how do we get our C, which is the concentration? To get your C, you say that we have 0.01 mole of what? CH3COONA, which we call a basic salt. Are you getting it? That is the total thing we have, plus 0.01 what? Mole of what? Water. That is the total thing we have. But this is a salt. The salt component is what you are looking at. Are you getting it? Now convert what we have in this salt. Convert it to what? Liter. Convert it to mole per dm cube or mole per liter. How do we get it? You say that what we have here is 100 ml plus another 100 ml of what? Sodium hydroxide will give you a total of 150 ml. Then plus another what? 100 ml of sodium hydroxide will give you a total of 250 ml. That means this 0.01 mole is inside 250 what? Ml of what? The solution. The solution, that is salt and water. Then you now say 1000 ml to 1000 ml of what? Solution. What will it be? We'll cross multiply. It becomes 1000 times 0.01 all over 250. That will be giving us what? This divide this is 4 times this 0.04 what? Mole per what? Liter. That will be the concentration of that salt in that total solution. Remember what we said. How we get it is we get the total volume of the solution we have. Solution containing this 100 ml of this, 50 ml of this, that is 150, and 100 ml of another sodium hydroxide added, that is 250. That the entire solution is 250 ml volume. Then we now put it here. We now bring it here. pKw, as we noted, is 14. So half pKw should be 7. So the final pH, when you add this one, will be equal to half times 14 is 7 plus half times what? 0.04. No. Half times, what is our pKa? We got our pKa to be 5. Yes. Plus half times 5. That will be 2.5 plus half log what? 0.04. We'll compute it. That will be giving you 9.5 plus, we now say 0.5 times log 0.04. That will be giving us minus 0.699. So we now say 9.5 minus 0.699. That will be giving us 8.801 to be the answer. That is the final pH when you add what? Another sodium hydroxide into it. You see why we say it's a basic buffer. You see the pH is high, meaning it's in base. It's a basic buffer. It's now a basic salt, no longer a buffer, because this second sodium hydroxide are finally neutralized the what? The remaining ethanoic acid, as we said. Now, but they say, what is the change in pH? change in pH is equals to this final pH minus initial pH. And what is the final pH? We have it to be 8.801. Initial pH is 5.0. They gave it to us, pH of 5.0. Therefore, our answer will now be what? 8.801 minus 5.0. That will be giving us 3.801, approximately 3.8. That will be the final change in pH of question number 2.